Right, so last time we just introduced the log, okay, how to change between exponent and log. And I think it was Caleb, I already marked yours, so you can take a look, okay? Changing from, I think was changing from exponent to log, okay? You mix up the order, so make sure, take a look at the mistakes, okay? Yeah. And then, so today we're gonna continue with that. We'll be covering log laws, okay? How to use log to solve some problems. And then last time we skipped the word problem, okay? And then today we're gonna go back and look at the word problems, all right? So let's begin. Okay, we'll start with page 95. So last time we mentioned that, right, to change either from log or to exponent or exponent to log, you just go from go with counterclock directions, right? And then you always start with the base when you do the counterclock. So for example, here we can use that idea to solve some of the simpler problems. Okay, so I'll demonstrate two questions here to show how that works. So for example, over here, the goal is to solve for x, okay? What's the x that should go in there that will make this equation work, okay? So looking with the log, it looks more difficult, right? But if we use counterclock, right? CC means counterclock, and then we change the log into exponential, then it will look more friendly, okay? So we start with the base, right? Base is x, and then we do counterclock like that, and then write it as exponential, okay? So Daniel, can you tell us what does it look like when it's in exponential form?
It's x to the power of 4/3 equals 16.
Yeah, very good. Okay, so you start with the x and then write 4/3, and then at the end you write 16 on the other side. Okay, so once you get to here, it looks nicer, right? Because we know that if the exponent has a fraction, you can write it as radicals, right? So how do I write this one in radical? Lily, what kind of root is outside?
It's 3.
Yeah, so we call that cube root. And then what do we put inside?
X to the power of 4.
Okay, very good. Okay, so equal to 16, right? So better than looking at log, right? We turn it into radicals. So our goal is try to find what x that will work. So we can slowly get rid of all the extra stuff on the side. So to get rid of the cube, we will do to get rid of cube root, we'll do the cube, right? So we'll do the cube on both sides. So the cube on the left side will cancel out the cube root. And then to get rid of, okay, I'll do it slowly, okay? So after I cube both sides, it becomes x to the 4 and 16 to the cube. Okay, and then next thing I want to get rid of is the x to the 4, the fourth exponent. Okay, how do we get rid of the exponent on the left side? Philip?
Root both sides by 4.
Yeah, so put on the fourth root on both sides. All right, so at the end, you will end up with x equals to the right side, okay? To find the right side, we can either do 16 to the third and then fourth root, but 16 to the third is pretty big, right? We can't really do it in the head. So we can do the fourth root first. So what is the fourth root of 16? Evan? The fourth root of 16. Evan?
So 2.
2, okay. So that will be 2 to the cube, right? So that will give you 8. So our final answer is 8. So it still takes a lot of time, right? So here we want to find a way so then we can do it faster, okay? So we can call this method 1, okay? Let's draw a line here. Method 2. So if you get something like this, there's an option, okay? You can either do the first way or the second way. First step is the same, okay? We still do counterclock to make it look nicer, right? So that one is the same. Now we already know, right, from the first method that we want to get rid of 4/3. So we could actually get rid of both of them at the same time. So instead of turning into radical form, what I'm going to do is to just add an exponent, right? Write out an exponent that's the reciprocal of 4/3. Okay, so 4/3 reciprocal. What's the reciprocal of 4/3, Angela?
3/4.
Yep, so I'm going to put 3/4 on the outside, on both sides. So 3/4 means the 3 on the numerator, it means cube, right? And then the 4 in the denominator means the 4th root. So basically I'm doing both things at the same time. I'm taking the 4th root and I'm also doing the cube, okay? So also from the exponent law, the exponents, if they are next to each other, right? You see it in the green circle, they can multiply together. So 4/3 times 3/4 will just simplify into x to the 1, right? And then right hand side, we know that means it's the 4th root x cubed. Okay, I'm gonna do cube on the outside, okay? Easier, not x, wait, 16. Right, so that will end up the same as 8. Okay, so that will be the way I would do it, right? Because I don't need to write out radical and get rid of 1 by 1. I just do the reciprocal exponent on both sides. Okay, can you raise your hand if you have no trouble with these questions? Okay, Evan, any questions? All right, so I'm gonna demonstrate one more and then you guys can go ahead, try the bottom ones, okay? So question B, compare with question A, right? The X is a different location, right? On the left side, X is on the base, right? In question A. On the right side, question B, the X is on the other side. So sometimes they will just give you a question like this without writing the X. Okay, a little bit lacking here. Yeah, they'll just say, please find, right, evaluate. They will just say evaluate or simplify, right? So they want you to find what this whole thing equals, okay? So what you can do is to write it out as equal to X first. So at least you have a left side and the right side. Then you can do counterclock, right? If you don't have a right side, it's difficult to write a counterclock. So we'll do the same thing again. We start with the 9 and then counterclock, right? So I can write an X and then this, right? So Waylon, how do I write it out using counterclock in exponential form?
It's a 3/3 to the power of x equals 9.
Can you say that one more time?
3√3
Hmm?
to the power of x equals 9.
So you have to start with the base. You have to start with the 9. Okay. So the correct way should
Oh,
be.
my bad.
Yeah.
Yeah.
That's why I circled it, right? Always start from base 9 and then Wayland, continue.
9 to the power of x equals 3 root 3.
Root 3. Okay, so once you turn it into exponential form, then you can apply what you learned before about this over here. Change it to same base. Take a look at page 87. You have variables in the exponents, right? If you look at question A, we can make them into same base, right? Once you turn it into one base, then you can drop the base. One base on each side, then drop the base. Okay, so if you forgot, you can look at that page. So over here, same thing. We have base of 9 on the right, left side, base of 3, right? 3 root 3 means 3 times square root 3. Okay. So from here, I think you know how to do this. I'll let you try this out. Okay. So turning to same base, simplify it, make sure it become one base. Then you solve for x. Okay. So you can raise your hand after you found the answer for this one. Does anyone have trouble? Like, doesn't know how to do the second step? The answer for this one is a fraction, okay? So it's okay if you have a fraction answer. Okay, it looks like it's taking a little bit longer. If you finish, please raise your hand. Okay, let's check the first step, okay? Just to see what you guys are doing. Susan, did you do anything in the first step?
I'm not sure how to transition to the second step.
Okay, what do you think what's the base that we want to change to?
3.
Yeah, very good. So look at left side, you have a 9, right? How do you change that into base of 3?
3 to the power 2.
So on the left side, you just write 3 to the power of 2 and then x. Okay,
Okay.
right? And then on the right side, it's already base of 3, right? But we need to write them in exponents. So how do I write it out? We want to rewrite it so everything has exponents instead of square root.
You would square it.
you don't want to get rid of it, you just want to rewrite it. So like square root of 3, how do you write it using exponent?
3 to the power 1 over 2.
Yeah, very good. And then the 3 is just 3 to the 1, right?
Mm-hmm.
Okay, so that's your first step. You make everything into exponent, turn into same base.
Okay.
Okay, and then continue from there. You want to simplify it, so it becomes 3 to the something equals 3 to the something, right? One base on each side, then you can drop the base and solve for the exponent.
Okay.
Okay, yeah, go ahead and try that. If you forgot, right, where we learned this, please look at your notes. It's on page 87. Okay, you guys did pretty well in the homework, okay, for the same base. Okay, let's look at the next step. How you did?
Does it become 3 to the power of 2x is equal to 3 to the power 3 over 2?
Very good. Okay, add the exponents, right? And then you drop the base, so the two exponents should equal each other. So that will give you 2x should equal to 3 over 2, right? So our final answer should be
3 over 4.
3 over 4. Okay. So this is how we can use just simply changing log, okay? Counter clock changing log. We can either solve question that's missing the base, right? On the left side, question A, missing the base, or on the right side, you want to evaluate the whole log, okay? You have the base, you have the inside number, okay? You turn into exponential and to solve. Okay, do we have any questions for these two examples? Okay, please raise your hand if you got everything down for question A and B. Okay, so then you may begin, okay? For the following question, only do question A, B, C, D, okay? E and F are a little bit special. You can try it, okay? But you can just do up to A, B, C, D, we'll go over them, right? So just do up to here. So you can raise your hand after you finish these 4 questions. And just to give you a hint, for questions A, B, C, the answers are integers. Okay, only question D is a fraction answer. Okay, Angela, which question are you working on now?
I'm working on D.
Okay, thank you. Yeah, sure, Philip. Okay, and Wayland, what question are you working on?
I'm working on D.
Okay. So I think by now everyone should finish at least A and B, right? A and B are pretty straightforward. You just count the clock. A is similar to the A on the top, right? Because you're missing the base. The other three, well, C and D. Question C is similar to the question B, but all the question can be done by counter clock. If you're confused with question D, what you can do is you put a bracket, right? This whole thing is one thing, right? The one in the bracket. So you start with the 2, counter clock, like that. Okay, because it has another exponent on the inside, but don't worry about that, right? It's stuck with the 32, right? Evan, which question are you on?
I'm on D.
Okay, can you tell us your answer for A? Evan, what's your answer?
I have 5 √32 to the power 3, but I think I need to simplify it, right?
The answer for X?
Yeah, wait, I didn't simplify it. Give me a
What?
sec.
Okay. Got it, Evan?
8.
Was that 8?
Yeah.
Okay. And Jenny, what's your answer for B?
I'm still working on it. Can I let you know?
Okay, yeah, let me know when you got it. All right, and Lily, do you have answer for C?
I got -5.
Okay,
Jason,
yes,
but for the first one, I got 16.
you have 16. Okay, thank you. And for question D, okay, Angela, what's your answer for D?
-11/5.
-11/5. Okay. If you have something different, okay, you can just shout out and then let me know. Okay, so you can raise your hand if you finished or you feel you've tried your best, okay, still couldn't get it, then we'll go over them, okay?
Hey, Jason,
Yep,
I got 512 for B.
can you say that again?
512 for B.
5/12?
512.
Oh, 512, okay. All right, anyone else want to add in your answer if you think you got different ones? Susan, do you have anything that's different?
I got 2 for B.
X equal to 2?
Yeah.
Right. Anyone else? All right, so we are going to go over the steps, okay? So don't worry if you couldn't get some of them, okay? With the steps, you probably will find out what's wrong, right? So of course, each question, your first thing to do is to turn it into counter clock, okay? So if you get this wrong, probably because you put the base at the wrong place, okay? So let's start with question A. Chris, how do you turn this into exponential?
X becomes the base, and then
Yep.
5/4. I mean, you can make 5/4 into like √4, and then times and the 2 to the power 2 to the 5, but then it equals to 32.
Yeah. Okay, so we won't turn it into root, okay? So this question is similar to the question A on the top. So we're gonna take the second method, okay? The second path. So we'll just leave it in exponential now. So from the experience before, right? If we have 4/3, we just apply the reciprocal exponent on both sides. Okay, so we're gonna do the same thing here. Both sides, I'm gonna add in an exponent of 4/5. Like that. Okay. So Evan, what will happen to the left side?
It becomes X.
Yeah. What about the right side?
Be 5
5.
is in the root sign and 32 to the power 4.
Yeah, 32 to the power 4. Okay. To the power 4, I'm gonna put it on the outside because 32 to the 4 will be difficult. So we will do the fifth root of 32 first. Okay. So what is the fifth root of 32, Caleb? Caleb, what's the fifth root?
Oh, it's 2.
Yep, so it'll be 2 to the 4. Okay, so the thing in the green bracket is 2. So that should give you 16. Okay. Let's look at next one. So Jenny, how do I change this question into exponential?
I did x1/3 equals 8.
X1/3 equal 8. Oh, sorry,
Yep.
X, I need to write X. Okay. So remember to change from to exponential, you need to start from the base. We look at this log form. Which one is the base?
Oh, 8 is the base.
Yeah, so you have to start with the 8 and then write the 1/3 and then you write the X. Okay?
Okay.
So you go in that order. So can you try one more time? How do I write it?
8 is to the power of 1/3 equals x.
Okay, so you can see the X is already by itself. And then 8 to the 1/3, what does that mean?
That means it's 2.
Yes, okay, it's a cube root, which will give you 2. Okay, so 2 is the X. So like I said, usually if you couldn't get the right answer, it's because the location of your form, okay, the base is at the wrong place. All right, let's look at next one, question C. Okay, Nick, can you tell us how do you change this one into exponential?
So does it become 7 to the power of x plus 3 is equal to 1/49?
Very good. Okay, so you start with the base is 7. You write x plus 3 and equal to the 1/49. So it looks like we can turn into base of 7, right? So left side is already base of 7, so I'm just gonna leave it there. The right-hand side, how do we write it out in base of 7? Claire, CZ?
7 to the power of -2.
Yep, okay, and then we drop the base because we have one base on each side. So x plus 3 is -2, and that will give you -5. Okay, last one is a little bit challenging because of the exponent on the log side, right? We never had that. But idea is the same, okay? We're gonna change it into exponential form. All right, Caleb, how do you change this one into exponential form?
I think you get 2/16.
2 to the 16.
2 to the power of 16 is equal to 32 to the power of 1 minus x.
Okay, and can you continue tell us what's the base that we want to change to?
We need to change it to 2.
Yeah, so left side will be the same. What about the right side?
Oh, after I did that, I changed it into a radical.
There's no radical here. We want to turn it into base of 2.
Oh, sorry, no, yeah, no, my bad. We put it as 5. Actually, no, I'm not so sure.
For the 32, right? Look at the number in the red bracket. Okay, the 32, how do I change that into base of 2? 2 to the what will be 32?
4/5.
2 to something equal to 32. How many 2's multiplied together can give you 32? Can you try it out?
Oh, 2 to the 5.
Yeah, okay, so you just write 2 to the 5. And then outside is still 1 minus x. Do you follow so far?
Yeah.
Okay, 32, I just rewrite it as 2 to the 5. So there's no root at all, okay? No fractions. Okay? Right, so we'll continue from there. We simplify the left, right-hand side, 2 to the 16. And then on the right-hand side, what do you do then? You have 5 there, you have 1 minus x there. What can you do?
You times it.
Yeah, so it becomes
2 to 5, 2 to the power of 5 minus 5x.
so now they both have 1 base on each side. So what can we do?
We find x now.
And how do we do that?
16 is equal to 5 minus 5x.
Okay, so we drop the base, ignore the base, we just solve for exponent. So this, if you isolate x, should give you negative 11 over 5. Okay, so no matter how the question change, what kind of thing they throw at you, right? If you see a log that has both sides, just change it into exponential form. Okay, but then you need to make sure you start with the base, put all the things in the right locations, right? Okay, please raise your hand if you are okay with these 4 questions, okay? Or you got the notes down, right? Maybe some of you skipped a question or 2. So after you copy everything down, please raise your hand. And then we're gonna look at E and F. Okay, very good. So in the future, right? So if you see questions something like this, for example, like if they say, please find x, log base 3, 27, right? What does that equal? So you just do counter clock, right? Start with the base of 3, right? And then you just ask yourself, 3 to the what will be 27, right? So the answer is 3, so that's it. Equal to 3 right away, okay? So for example, they will say, they will give you something like this, log base 2, 8, what does that equal? Right, so you do counter clock again. 2 to the what will equal to 8, right? 2 to the 3, so you finished. Okay, so you don't always need to see the x, right? You just imagine the other side, right, is the invisible x, and you do counter clock in the head. All right. So okay, so let's look at the bottom question here. So as you can see, for a counter clock to work, you always have to have both sides, right? You have log, and then the base, and then something, right? After the log, and then the other side. Okay, so you have the A, I put A here, B, C, right? You always have 3 parts. So if I change that into log form, you have to start with the base. So A to the C equals to B. Right, start with the base. A to the C equals to B. the order that you write it. So you never touch the inside. So if you look at question E now, the weird thing about this one is inside the log, right? The location of the B, you have the log inside. Okay, let me highlight it, right? The B here is this. Okay, because this question has 2 log. That's what makes it confusing. But then you only focus on the log on the outside, right? Because in the bracket, even though it has a log, but you cannot touch that. Okay, so when you try to change into exponential, it will be wrong to start with a 4 and do counter clock. Okay, so that's why I explained this. You have to start with the outside log to change. Okay, let me reverse that, right? So it will start with the 2, right? So that's the location for the A, and then to the C equals to B. Understand? Okay, so you have multiple log, but you need to know which one to start. So the general rule is to start from the outside one. Okay, if you get a 1 log inside another log. So if I do that, what does the form look like now, Daniel? What's the exponential form?
Two to the power of -1 equals log 4x. Wait, no, log base 4 of x.
Yes, very good. Okay, so if we say log 4x, it will look like this. Then the base will be 10. Okay, if it's invisible. So very good. All right, so we have to say log base 4 of x. So once you get to here, now we can just focus on 1 log, right? Each time you make a turn, right, make a counter clock, one of the log disappeared. Okay, so I'm gonna rewrite this. 2 to the -1 is half, right? And I'm gonna write it on the right hand side. So like flip the left and right side, okay? So I put a log on the left side because we're used to having log on the left. 2 to the -1 is half. So I'm gonna write it on the right side. Okay, because when we do counter clock, we are used to have the log on the left side. That's why I flipped the order. Okay, any questions so far? Can you raise your hand if you know what I'm doing here? Okay, Evan and Susan, any questions on what's going on here?
No.
Okay, so now we want to do 1 more counter clock, right? Each time when we do counter clock, the log will disappear. Right, so Waylon, how do I change this into exponential again?
So 4 to the power of 1 over 2 equals x.
Yes, so what's x equal then?
2.
Yes, okay. So the half means the square root, right? So that will give you 2. So this is how we approach this kind of question when you have a log inside a log, okay? You just continue doing counter clock, but make sure you start with the right base. So the rule is to start with the base that's on the outside, okay? So this one, I give you a little bit challenging, right? I give you triple log. 1 log inside another log, and then inside another log. So you need to do the counter clock a couple times, okay? So let you guys try it, have fun with it, right? Do the turning. Doesn't matter if you get it right or wrong, just give it a try, right? It looks very special here. So if you have an answer, you can raise your hand. I forgot if the answer is integer or not, okay? But we'll find out, okay? Okay, so I would like to know which base did you start with? We have 3 bases, right? We have base of 2, base of x, and also base of 5 here. So Nick, which base do we start turning?
Two.
Okay, very good, right? So you should start from the outside one, go like that. And then to the inside, okay? The inside is this whole big chunk, right? So once you do the first counter clock, the outside log will disappear, right? And then you continue. Move on to the next log, next layer. And then next layer, okay? Okay, the answer for this one, it won't be a fraction. It will be something that has radicals, has root. Okay, so if you get something like that, it's okay. All right, so I'll show the first counter clock. So start with the 2. So 2 to the 2 should equal to the yellow part. Right, but then I like to write it in the way we are used to, right? So let's put the log on the left side. So we'll do 2 to the 2, this side. So erase this one, okay? Keep the log on the left side. And 2 to the 2 is 4, right? So let's write it as 4 instead, right? Looks better. Okay, now if I want to do the counter clock again, Chris, where do we start if I want to counter clock again?
The log x.
Yeah, so x. And then how do I write it in exponential form?
It'd be x to the 4,
Yeah,
and then equals to log 5, 1 to 5.
yeah, base 5, 1, 2, 5. Okay, continue, keep on going from there. You can raise your hand if you think you found the answer for x. So right now, right, the yellow part will reduce down to that one, right? X to the 4 equal to the inside. So it looks like the x is already kind of isolated, right? X is on the left side now. Okay, a few of you already got the answer. Let's take a look. Angela, what's the answer you have at the end?
I'm not sure how to say this, but like the 4th root of 3.
4th root of 3, like that?
Yeah.
Okay. Callum, what about you? What's your final answer?
I'm not so sure. I only got up to 5 to the power of x to the power of 4 is equal to 125.
Oh, so you change the log form, right?
Yeah.
Yeah, yeah, okay. How about you, Sophie? Do you have a final number for x?
I got 3 to the power of 1/4, which is the same thing.
Yes, 3 to, yeah, it's the same thing. Okay, so let's take a look at this one. This, once you get to here, there are a couple ways to go ahead, right, to continue. So you can also do what Caleb did, right? Do the counter clock one more time. So we can write it as, okay, I'm gonna draw a line here, okay, to show different ways. So if I change it into exponential form, we start with the base of 5, right? It'd be 5 to the x to the 4, right, equals to 125. And then this x to the 4 is the exponent. 5 is the base. And then on the other side is 125. So 125 and 5, they could change it to base of 5. Make it same base, right? So we can, the left-hand side stay the same. The 125, Caleb, how do you write it with a base of 5?
Um, 5 to the power of 3.
Yeah, very good, right? So once you get there, you make them same base, then you drop the base. So you have x to the 4 equal to 3. And then to get rid of 4, you do the fourth root, then that will give you the final answer there. Okay, so that's one way to go. The other way is if you are cautious enough, right? And then you look at this right-hand side, and then you recognize, okay, I can do the counter clock in my head. I will start with a base 5. 5 to something has to be 125. So 5 to the 3 has to be 125. So this whole green circle is actually just 3. So you go straight to here. Okay, that green circle is the 3. Because 5 to the 3, 5 to the cube is 125. Right? So left side you don't touch, right? X to the 4, because x is to the 4 is already sort of isolated, right? And then you, of course, the next step, you get rid of the fourth exponent, you get the same answer. So two different ways, right? If you have the base, you have the 125, you can just do the counter clock in the head. Okay, any questions? Okay, if you are ready to move on to the next part, you can raise your hand. Okay, Waylon, do you have any questions about this one? All right. So these two questions, okay, are pretty unique. You have to know which base to turn. Yeah, so I've seen this, these kind of questions appear on tests. So that's why I throw these two here. All right, so since the log and exponent, they are related, right? You can change between them, right? Exponential form and log form. And for exponent, we have exponent rules, right? Remember this one, multiply the same base, you can add an exponent and so on. So therefore, for the log, we also have log laws, right? Log rules. So since the log represent the exponents, so sort of connected with the exponential rules, okay? So I'm gonna just prove one of them. The other one we won't prove, okay? Because it will take a lot of time. We'll just learn how to use it, but I'll show you how we prove one of them. So if you're interested, you can also try that, okay, in the same way. So let's look at the top. On the left side, okay, so look at the left side here. This part I put circled it. X equal to b to the n, right? X equals to b to the n. If I change that into the log form, you would write it as log base b, right? Remember, you always start with the base of the x will equal to n. Okay, it's like doing this, b to the n equal to x. You start with the base, log base b of x equals to n, right? This is changing from exponent to log. Right, CZ, can you help us change the second one for the y?
Log base b y equals to k.
Yeah, very good. Okay, so what's the point of doing that? Okay, it's gonna help us show our first log law, right? So on the left side of the chart, for the first one, okay, we're looking at the first one, b to the n plus k. Okay, the exponents are adding, right? So it's the same as we can add the exponents when they are having same base and multiplying. Okay, let me try one more time. So I can write it as b to the n times b to the k. Right, and b to the n times b to the k is the same as x times y. It's because of the red circle. Look at the top. B to the n is x. B to the k is the y. So that's why it becomes x times y. So we have this part right now. Okay, can you raise your hand if you understand the left-hand side? Okay, the one in the red box, how we get there? All I did is separate it and then replace it with x and y. Okay, so now we are going to use this form. You see I'm putting brackets there. And then I'm going to turn it into log form. So we start with the base of b. So I write log base b, right? Of the other side, so of xy. Okay, and then it will equal to the exponent. Okay, equals to n plus k. Okay, all I did is to change the red box into log form. Okay, can you raise your hand if you follow that? Okay, Kalen, Evan, any questions? Okay, I just changed the red box into log form. Waylon, any questions? Okay, and then now if we look at the top right corner, the one I have yellow highlight, the m is actually log b of x, right? Base b of x. K is log base b of y. So I'm going to replace it. M is log b of x plus k. K is log base b of y. So that's where we get our first rule. Okay, so if you finish copying these down, please raise your hand. So the other rule can be found with the same idea, okay? So each of the log law, it has its corresponding exponent law, okay? So please raise your hand if you copy the notes down, and then we're gonna look at some example. How do we actually use it, right? What's the point of having these log laws? Because the most important thing is to know how to use it, right? But before you know how to use it, right, it's also beneficial to know where it came from, right? Where do those laws come from? Makes it more reasonable, right? It's not just dropping off the sky. Okay, please raise your hand if you finish copying down the notes here. All right, so let me make up an examples and show you what kind of question they usually will give you, right? So for you to apply this. So for example, they will say, okay, I have log base of 2, and then let me see, 16, okay, plus log base 2 of what? 4, okay, I'm just trying to make it up. So this part, right, this is the question. They want you to find out what that equals. It's kind of like the right-hand side of our formula, right? So the log law tells us that if you're adding the 2 log, then you can multiply, right? You can simplify, combine them together, and then multiply the 2 number on the inside. You can write it as log. The base still stay the same, and then inside will be 16 times 4. So that's what the log law is telling you to do, right? With the log law, you can make the log simplify, right? Make it shorter. So once you get to there, 16 times 4 is 64. Okay, and then once you get there, you don't stop there. You ask yourself, base of 2, right? 2 to something has to be 64. 2 to some exponent has to be 64. What exponent will work? Okay, 2 to the what will equal to 64. Lily?
2 to 60. Oh, yeah, 2 to 6.
2 to the 6. Yeah, okay, 2 to the 5 is 32, right? So we need one more. So 2 to the 6. So that means the whole thing will equal to 6. So that's your final answer. Okay, so that's how you would use this kind of log law. Okay, one of the examples. So because I made this one the number smaller, okay, usually the number could be bigger, then it's better to simplify it with the law first. If you look at the left side, right, because these are pretty small, right, 16, 2 to the 4 will be 16, right? And then for the second term, 2 to the 2 will be 4. So 4 plus 2 also give you 6, right? So of course you get question like this. It's faster if you just do it individually, right? So I'm just showing you that they both works, right? So you can multiply it and find the answer, or do it separately, still finds the answer. Okay. So let's look at the next rule. So next rule is dividing, okay? So log of x over y. So for example, I'm gonna just use base 10, so I don't need to write a base. So for example, if I have 25 over 3, right? This is division on the inside. Then I can write it as log 25 minus log 3. Okay. So just an example, and then if you like, you can simplify each one. Okay, right now just know that that's what it means with numbers. And then next one, if you have log, let's say 25 to the 3. Okay, so the exponent here is the n. Okay, the 25 is like the x. Okay, the base here is 10. Okay, 25 is the x. Any questions so far? So what the rule tells you to do is the exponent can go to the front. Okay, you can drop it down. So it'll become 3 and then log of 25. Okay, so if we have base of 5, right? Let's say we have base of 5. Then log base 5 of 25, it becomes 2. So it becomes 3 times 2. So give you 6. Am I going too fast here? The 20 log base 25 is the 2. Okay, that part we did a counter clock in the head, right? 5 squared is 25, so that's why it's 2. Okay, can you raise your hand if you understand how we get the 6, right? All the way from here to here. Let me know, okay? If any step you found confusing, okay? Then I can explain more. Right, so you look at the question here, right? Very confusing here, but then with the log law, then you can simplify, right? Much easier. Daniel, Evan, Justin, Nick, and Susan, do you have any question about the steps here?
Could you explain it one more time?
Yeah, okay. Which part you got lost?
How you get the 6?
Okay, so all the way, right? Okay, so I will start with the beginning part, okay? Let me cross that out. So if you have an exponent on the inside, okay, the exponent on the inside is a 3. You can, based on the rule, okay, we call this the log of power. The 3, you can drop it to the front. Bring it down, okay? So it will look like 3 times log base 5 of 25. Do you follow so far?
Yeah.
Yep, okay. So now we just focus on this yellow part. Okay, just look at that alone, okay? So I write it on the side. And I want to find out what this part equals. So for this part, I just do counter clock in the head, right? In my head, I think about 5 to what will equal to 25. You ask yourself, right? 5 to what will equal to 25? Okay, so Susan, what do you say? 5 to what exponent will be 25?
2.
Yeah, so that yellow part will be replaced by 2. 3 times 2. Oh, sorry, it got crushed. Okay, so if that part is a 2, then 3 times 2 give you 6. So 3 times 2. Hold on, let me share the screen. Okay, so 3 times 2, this is the yellow part, right? Oops, wrong. Here. 2, right? The 2 can replace with the log 25. So that's give you 6. Got it now, Susan?
Yes, that is perfect. Thank you.
Anyone else have questions? Okay, so the log law here, the most common ones are the adding, right? Adding can turn to multiplying, subtracting, you can turn to dividing, right? Vice versa, right? And then the most important one, unique one is the exponent. You can bring it down to the front. Okay, Jocelyn, do you have any questions? Jocelyn?
No.
Yeah, okay. So we're gonna try some questions, all right? So usually is from, you can work both ways, right? Depending on what they want. You can either go from dividing to multiply, divide to add and subtract, or add and subtract back into multiply, divide, okay? So look at the example here. So over here, it has a mix, right? You have log. First thing you need to check, make sure all the base are the same, right? We have base of 4, right? For each one of them. Then the log law can be applied, okay? It has to be same base. So adding, you can then turn into multiplying. Subtracting, you can turn it into dividing, right? So dividing means you put it into denominator. Okay, so I'll show the first one, okay? You can just write a big bracket, right? So the first 2 log they are adding, so you can write it as multiplying. 6 times 64 over 3. Minus means dividing, so you divide it by 8. Okay, and then simplify whatever that's inside. I'll let you do that. Okay. So find out what the inside number becomes. Okay, you can raise your hand if you have a inside number. The divided by 8 part, right? You can also write it as over, right? Over 8. That's also dividing. Okay, please raise your hand if you have the inside number. Okay, Evan, what's the number inside?
Is it 16?
Okay, let me check. Angela, do you have the inside number? Is it 16?
Yeah,
Okay,
I have the same.
yeah. All right, so once you get to here, don't stop there because you look at the base. Base is 4, right? Inside is a 16. So you ask yourself in your head, right? But ask yourself, 4 to what will be 16? Okay, so Kalen, what does it equal?
2.
Yeah, okay, so this whole question answer is 2, right? So that counter clock is the foundation, right? Otherwise you can continue from there. You'll be stuck at base 4 of 16, okay? So you do the counter clock in the air, right? 4 to something has to be 16. So that answer is 2. Okay. Let's try another one. Okay, can you raise your hand if you're ready to look at next one? Okay, Daniel, Evan, and Jenny, do you need more time? Okay, so question B on the right side, you can see I have a bigger space, right? So this one is going backwards, okay? So if you look at the previous question, it's kind of like going from here, the yellow one, and then try to go back to there. Then we call that expanded form, right? Expanded. We make it longer. If you want to go back and then write it out using adding and subtracting. Okay, so that means at the end, you will have several logs, okay? And no exponents, okay? So expanded form, okay? Make sure you write it down. Only plus or minus logs, okay? And no exponents. No exponent means you need to use your third log law, okay? If you look at the third one, if there's an exponent, you need to bring it down to the front, right? The 3, you bring it down, okay? I left a bigger space because there are several mistakes that could happen here, okay? But I want you to try it. So maybe some of you will get it right the first time, some of you make a mistake, okay? But we'll learn from it. Right, so everyone try it, go backwards, turn it into add and subtract. So once you have something down, okay, whether you're not sure or not, okay, you can raise your hand. We'll take a look. Okay, if you have anything, you can raise your hand. Okay, you can think about what we did before, right? If you have a 6 on the top, so you write log and you write add, right? Add log, and then 64/3. And then there's a dividing, right? Over 8, you write subtract. So if it's multiplying, it becomes add. If it's dividing, becomes subtract. Okay, going backwards. Hello, Eric.
Hi, Jason.
Yeah, I made it.
Yeah.
Okay, we're on page 97. Okay, since no one raised a hand, only one person. Let's see how far you got to so far, okay? Daniel, can you, do you have any steps that you tried?
Yeah, I just finished.
Oh, okay. Can you tell us what's the first thing you did?
Log base 1. So I just changed it so it became log base 1 x and then minus log base 1 and then brackets 2y over 3. That's 2y to the power of 3.
Okay, so if it's invisible, it's not base 1, it's actually base 10.
Oh, okay.
Yeah, it's like invisible 10, then we don't need to show it, okay? If there's no base there, it means 10. Okay, Philip, do you have the same thing for the first step?
Yep.
Okay, can you tell us what you did next?
Then you can expand log 2y cubed into log 2 plus log y cubed.
So minus log 2 and then?
Plus log y cubed.
Plus log y cubed. Okay. And did you do anything else after that?
You can do exponent, but
okay. Yeah, because there's an exponent, we need to get rid of
yeah.
it. So it becomes?
So that becomes 3 times log y.
Okay. So let me write it down. That's 3 times log y. Okay. Anyone else? Thank you. Thank you, Philip. Anyone else has something different? Any steps that's different? Chris, what do you think? Do you have anything? How far did you get to, Chris?
I wrote down log. I wrote down like the first step, and that's all I got to.
Okay. How about you, Angela?
I didn't do past this part.
Which part?
Like where we're at right now.
Oh, you got to here, is it?
Yeah.
So everything the same? Yeah.
Yeah.
No? Okay. Okay. Anyone else has something different? Okay. So if not, that means well, whether you, I don't know how far you get to, okay, but this is very good example of a few easy traps to fall into. Okay, so that's why I leave the space here. So I'll explain. There are 2 things that we need to avoid doing here. Okay, so let's write. Please copy this down first, and then write wrong. Well, first step is right. Okay, but there are some something wrong after that. Okay. So it's good to make a mistake so we know what to avoid, right, in the future. Okay, so please copy this down first, okay, and raise your hand, and I'll explain which part is wrong. We'll do the correct at the bottom, okay? So raise your hand when you finish writing. Okay, if you finish copying, please raise your hand. Okay, Evan, do you need more time? Evan, are you there? Okay, I guess, Evan, are you here? Okay, so first, let's go over the mistake. One of the common mistake could happen. Okay, even though it's not here. Okay, he did not. Philip, I think it was Philip, right? Philip did not make that mistake. Is for this part. So this does not equal to 3 log 2y. Okay, the exponent, you cannot bring it down yet. Okay, because there are two things on the inside. You have the 2, you have the y cube. Okay, so for the exponent law, the block of power, the inside has to be only one base, right? Only x to the n, like 25 to the 3, then 3 can bring it down. But if the inside has more than one base, you have the 2 and the y cube, you cannot bring it down yet. So you need to separate it, okay? So he did very well, right? He separated into adding, right? So then you have y cube. Then the cube, you can bring it to the front, okay? Then that's okay. So remember, you cannot bring it down too early, okay? So that means that also tells us leads to our second common mistake. Rather at the correct step here, okay? So first part is fine, okay? Change the pen. We have log x minus log 2y cubed. Okay, this is all good. It's the next part that's wrong, because we have a bracket here, right? 2y cubed. So when you split that one, you need to keep a bracket as well, okay? Because the minus is minusing the whole log. So it'll be minus the bracket log 2 plus log y cubed. Okay, do you see the difference? One has bracket, one doesn't have brackets. Okay, because the minusing part is minusing both log, okay, minus the one in the red circle. Okay, so now if you want to get rid of the log, it will affect the sign inside. So it'll be log 2 minus log 2 and then minus log y cubed. And then of course the cube, we can bring it down now. Okay, so the correct way to expand should be this one. Okay, so two common mistake here. The first one is up here. Okay, don't bring down the exponent too early. The second common mistake is the no bracket. Okay, no bracket, no bracket. Okay, so make sure you watch out for that. No problem, Evan. Yeah. Okay. So copy the notes down, okay? And then raise your hand when you're done. And I think we should have a break now, okay? So we'll have a break until 11:25. And then after that, we'll look at the word problem, okay? We'll continue at 11:25.